This conference will now be recorded.
So from today onwards, we'll try to understand Terraform. So far we discussed about what is cloud computing, why do we need cloud computing, what is cloud services, right? We already discussed about various cloud services in AWS like EC2, EBS, EFS, S3, VPC, auto scaling groups, IAM. So we already discussed why do we need cloud computing, what are the advantages with cloud computing. Now we'll try to understand Terraform. So before we start Terraform, we are not directly getting into the Terraform. First, we'll try to understand the challenges, the problems we have with managing that infrastructure in a traditional way. So as we already discussed in the demo itself, right? You can manually provision the infrastructure, you can manually update the infrastructure, we can manually manage, update, destroy the infrastructure using GUI, right? So there are a lot of challenges, right? With manually, there is a possibility for human errors. It is going to take a lot of time, right? And it will bring the inconsistency. It will bring the inconsistency because manually you are building your resources, your compute resources, storage resources, and network resources. Manually you are creating the required storage, EC2, firewalls, networks like that. If you are manually building, there is a problem with the consistency, there is a chance for human errors, and there is no automation, there is no tracking who is doing what with your infrastructure. So to overcome these challenges or drawbacks of manually managing the infrastructure resources for your applications, there is a concept called IAC. So Terraform is basically IAC tool. Terraform is a infrastructure as a code tool. Infrastructure as a code. IAC. IAC tool. So first we'll understand, before we get into Terraform, we'll first understand what is IAC. What is infrastructure as a code? Why do we need to go with infrastructure as a code, and what is the advantages with infrastructure as a code? So infrastructure as a code is the way of managing infrastructure as a code. IAC is the way of managing and provisioning of infrastructure resources through code instead of a manual process. IAC is the way of managing and provisioning of infrastructure resources through code instead of a manual process. Provisioning in the sense creating, managing in the sense that can be updating or destroying your infrastructure resources. Provisioning is nothing but creating. Managing is nothing but it can be updating the infrastructure resources, or it can be destroying the infrastructure resources via code. So infrastructure as a code is the managing and provisioning of infrastructure through code instead of a manual process. Instead of manually creating a servers, networks, load balancers, or security groups like that, you can provision that infrastructure. We can manage the infrastructure as a code. So with infrastructure as a code, right, we will write the code. We'll write the code, the infrastructure code. We will develop the files. We will create the files. We will create infrastructure files, and in those files, we are going to define with infrastructure as a code. We are going to create a files that contain within IAC. You will write a code that contain your infrastructure specification. With IAC, you are going to write a code that contains your infrastructure resources specification, which makes it easier, to edit and distribute that code. And it also ensure that you can provision the same environment every time. By coding and documenting your configuration specification, you are going to write a code. That code will act as a documentation for your infrastructure resources also. So with infrastructure as a code tools, you are going to write a code that contain your infrastructure resource specification, which makes it easy for you to create, update, delete and destroy those infrastructure resources. And also multiple teams also can work on the infrastructure provisioning by sharing that code or distributing the code. And also it will ensure that there is a consistency in your infrastructure. You are going to get the same environment every time. However many times you run, you are going to get the same set of infrastructure resources. So that infrastructure as a code also will act as a documentation. So you can track, you can maintain your infrastructure as a code files into your version control systems, SCM tools. So you can track who is modifying what on your infrastructure resources, right? You can audit what changes has been done to your infrastructure, and you can also take that infrastructure as a code as a documentation for your infrastructure configurations. So what are the advantages? What are the advantages with IAC tools, infrastructure as a code tools? So can I improve the speed of deploying my infrastructure resources, like creating a servers, networks, storage, firewalls, whatever is required? Yes. So you are defining everything as a code. So you can automate the process. You can automate the process of provisioning the infrastructure resources, updating the infrastructure resources, and destroying the infrastructure resources. And it will reduce the cost also, cost reduction, because you are automating, you are eliminating the manual process. You can hire some people who can create infrastructure as a code for you. And once the code is available, you can run n number of times by modifying that code to update or destroy or provision your infrastructure. And it will reduce the errors. It will reduce the errors. You are not manually creating any compute resources like EC2 instances. You are not going to provision any storage resources manually via console. You are not going to manually create a networks, firewall, security groups, route tables, such as like that. So everything you are defining as a code. So there is a consistency. And you can reproduce your infrastructure. You can create a consistent and reproducible infrastructure. It will reduce the human errors, and it will improve the consistency. And also we can eliminate the configuration drift. Configuration drift in the sense, whenever you are deploying some application, you may need to create a new server and you may need to install required softwares every time. And if you are continuously doing lot of patches, lot of updates to that server, and you may lose the control. Manually you are doing, you don't know what version of the software is running, what version of the OS is running, like that you may lose the control. But if you are using infrastructure as a code, it will eliminate the configuration drift. Configuration drift in the sense, the conflicts which is causing when you are keep on updating your servers with update, latest version of the softwares or applications. So is everyone clear what is infrastructure as a code? What are the advantages with this infrastructure as a code tools? We already discussed in the first day of our demo itself, but again, since we are starting Terraform today, again I am repeating this one. Is everyone clear what is infrastructure as a code? What are the advantages with infrastructure as a code? Again, when it comes to infrastructure as a code, there are two types of approaches. Declarative and imperative IAC. Declarative and imperative. So there are two approaches to automate your infrastructure resources. Your infrastructure resources like servers, storage, networks, firewalls, load balancers, databases, Kubernetes clusters, etc. Right? So instead of manually creating your infrastructure resources like a server, storage, networks, firewalls, load balancer, databases, Kubernetes clusters, etc., instead of manually creating, you can use the infrastructure as a code tools where you are going to define everything as a code. So you will have all these benefits. But when it comes to infrastructure as a code, there are two types of approaches. There are two types of approaches: declarative approach and imperative approach to infrastructure resources, right? So in a declarative approach, you only need to define the desired state. What is your desired state? What you are expecting in a infrastructure, right? What you are expecting. You need to only define the desired and final state, final condition. So with the declarative approach, you only need to define the desired and final condition of your infrastructure. You need to define the desired and final condition of the infrastructure. You no need to go to in detail. You no need to worry about in detail how it should be achieved. You no need to worry about how it will be achieved. You just define what you need. Suppose you have a requirement, I need 10 virtual machines with 16 GB RAM and 2 core CPU. Suppose you need a 5 block storages of 20 GB capacity, or you need, right, one load balancer, network load balancer. So you just define what you need. You only need to define the desired and final condition of your infrastructure without going into detail on how it should be achieved. You no need to worry how it will be achieved or how it should be achieved. You just define what is you are expecting, what you need, your desired state, your final condition of your infrastructure. So the platform the platform will take care itself. How it should be achieved will be taken care by platform. That infrastructure as a code software, will take care how it can be achieved. You just define what you need. As a infrastructure as a code tool user, right, as a Terraform user or whatever infrastructure code tool you are using, you just define what you need, leave everything to that tool how to achieve it. So if you are going with infrastructure as a code, and again if you are going with a declarative approach, it requires less knowledge. The user is no need to have a more programmatic background or more domain background. It is not required. If you are going with the infrastructure as a code, again that is declarative approach. So it is a preferred method. It's a dominant method because it requires less knowledge on the user's part. It requires less knowledge on the user part, and again it is idempotent. Idempotent in the sense always it will produce the same result. In every time you run that infrastructure as a code with your code using the declarative approach, always it is going to produce the same result, and the users requires less knowledge because you are just defining what you need. But who is taking care how it can be achieved? That tool, that IIC tool is going to take care how it should be achieved. So this is declarative approach. But there is some infrastructure as a code tools. There is some infrastructure as a code tools that is imperative approach, procedural approach or imperative approach, right? So you have to define if you guys are using imperative approach, you have to define step by step commands. You need to execute step by step commands to achieve the required configuration. So you need to run step by step procedural, one thing after the other. You need to execute commands to achieve the required configuration. And here you have to have a detailed knowledge. You have to have a detailed knowledge. Here, you can be very detailed and create a complex configuration. You need to have a more control, having more control on the task. But you need very detailed knowledge on how to use that commands and how to execute that commands. That is imperative approach. So declarative, you just define what you need. Declarative, you just define what you need. You leave everything to that tool that will take care how to achieve that desired state. But if you go with imperative, you need to write a step-by-step commands or step-by-step tasks, what needs to be done, in which order it has to be done. So you need more skills on those tools to execute or use those code. So is everyone clear what is declarative and what is imperative? When it comes to infrastructure as a code tool, declarative is preferred because you just define what you need. You let the tool to take care how to achieve that desired state. You no need to worry. And this is idempotent. It will always produce the same result. Even though you run 10 times without modifying your code, if you run 10 times, it will always produce the same result. And when it comes to imperative, you must define step by step. You need to inform how to achieve that one also. Is everyone clear? What do you mean by declarative and imperative when it comes to infrastructure as a code tools? And when it comes to Terraform, it's a declarative tool. When it comes to Terraform, it's a declarative tool. So declarative approach. When it comes to Terraform, you are just defining what you need. Is Terraform is going to take care? Will Terraform is going to take care how that desired state can be achieved in that respective platform or providers? Yes. So Terraform is a declarative IAC tool. Now, before we start Terraform, let's understand the difference between provisioning and configuration management. Provisioning tools and configuration management tools. Again, there is a lot of confusion between this provisioning and configuration. So what is provisioning? What is provisioning and what is configuration management? So some tools are provisioning tools, some tools are configuration management tools. So what is provisioning? First of all, let's understand. So provisioning is the process of setting up your IT infrastructure. Provisioning is the process of setting up that can be creating, updating, like this. Create or update or delete or destroy, basically. That is kind of a destroy. So provisioning is the process of setting up our IT infrastructure resources like a virtual machine, storages, networks, databases, and access to those resources and make them available to the users. This is provisioning. Provisioning is the process of setting up IT infrastructure resources like virtual machines, storages, networks, databases, and access to those resources and make them available to the users is called as a provisioning. And when it comes to configuration management, it is different. The configuration job is done by a different tool. A configuration job is done by a different tool. So configuration management comes after provisioning. Configuration management comes after provisioning. Once you provision your virtual machines, once you provision your storage networks, like that, this configuration comes after provisioning. Configuration management comes after provisioning. It means installing the required softwares like Tomcat, Docker, Kubernetes, like that, or MySQL, like that. So configuration management comes after provisioning. It means installing the software and configuring the servers and maintaining them. So configuration management is different, provisioning is different, provisioning infrastructure is different, configuring infrastructure is different. Understand, provisioning is nothing but creating the virtual machine, storages, networks, like that. Configuration in the sense, once you provision that infrastructure, you are going to install some softwares and you are going to deploy some applications that we call it as a configuration management. But when it comes to some IAC tools, it can do both. It can do both, but one is typically more equipped for specific tasks, right? Some IAC tools can do both, but some tools can do only provisioning, not configuration management. So they are designed for specific requirement only. So when it comes to Terraform, Terraform is widely used as a provisioning tool. When it comes to Terraform, Terraform is widely used as a provisioning tool. But Terraform can do little bit of configuration management also, but that is not designed. That is not designed for configuration management, but little bit of configuration management, can be done by using Terraform. You can execute some scripts using some provisioners, right? You can execute some script in Terraform, but that is not matured enough for configuration management. Terraform is widely used for a provisioning tool only. But when it comes to Ansible, Ansible can do provisioning also, Ansible can do configuration management also, but Ansible is more focused on configuration management. Using Terraform also you can do the configurations, but that is not matured enough. When it comes to Ansible can do the provisioning also, but that is not matured enough to manage the infrastructure. So Ansible is more focused on the configuration management, but even though you can provision the servers, but it will not maintain the state. If you guys use Ansible, using Ansible also you can create a servers, you can create a networks in any cloud like AWS or Azure. There are modules, but they are not maintaining the state. Is kind of a that is kind of a procedural language. Do you need to define in a proper order what needs to be done? First, that a task in Ansible, everything is a task. You need to define each and every task, in what order you have to execute the task also you need to define when it comes to Ansible. But it is only works very well with configuration management. Terraform will work better for provisioning the infrastructure. If required, can we use combination of both? Can I provision the required virtual machines, storage, networks using Terraform? Once the infrastructure is provisioned using Terraform, can I run some configuration scripts, Ansible scripts against that infrastructure, whatever is provisioned for doing the configurations? Yes. So you can use combination of these two also. You can use Terraform for provisioning the infrastructure and managing the infrastructure. You can use Ansible. For doing the configurations also if required. Clear? What do you mean by provisioning tools? What do you mean by configuration management tools? And again, what is what for which any questions, any confusion here? You need to understand all these things first of all before going to Terraform. What is provisioning? What is configuration management? Now again, when it comes to infrastructure, the infrastructure can be mutable infrastructure, that infrastructure can be immutable infrastructure. Can we install Java Tomcat using Terraform? I told it can do some little bit of configuration management also. You can run some script, you can execute user data, you can execute some shell scripts using Terraform also in your servers, but that is not matured enough to use as a configuration management. So you can do that using Terraform. You can provision the infrastructure using Terraform. You let configurations for other tools. Leave it for other tools. We'll understand slowly. So what are the ways to create an infrastructure? You will understand slowly. You can run any script using Terraform also, but that is not matured enough, or that is not a right way to manage the configurations. You leave for configuration management tools, and you focus in Terraform, you only use for provisioning the infrastructure. Now, when it comes to infrastructure, again, there is a mutable infrastructure, there is a immutable infrastructure. There is a mutable infrastructure, there is a immutable infrastructure. Let's understand what is what. What do you mean by mutable? Let's say I have one server. Let's say I have one server and I want to deploy some application in this server. I want to deploy some application in this server. Let's say I want to deploy my application. Let's consider this is Java based application. Let's say you might have installed, just to give an example, you might have installed Tomcat 8.5 and Java 1.8 and you deployed your application. You deployed your application. You deployed your application, right? Now, mutable, immutable infrastructure in the sense, first understand what do you mean by mutable infrastructure. So again, when it comes to infrastructure as a code tool, tools can also differ by what type of infrastructure they are building, whether it is a mutable or immutable. So you have to decide with what approach you want to go, whether you want to go with mutable infrastructure, whether you want to go with immutable infrastructure, that you need to decide before you choose any tool. Before you choose any tool itself, you need to decide whether I need to go with a immutable infrastructure or whether I need to go with a mutable infrastructure. So at the later stages, shifting from one to other is costly, which means you need to do a lot of rework. You need to do a lot of rework. Later, if you try to switch from mutable infrastructure to immutable infrastructure, later it is very difficult to change your code, your infrastructure as a code again, and your configurations again. First, you need to decide whether I have to go with mutable infrastructure, whether I have to go with immutable infrastructure. In the first itself, you need to decide. So let's understand what is mutable infrastructure. So mutable infrastructure in the sense, it can be changed to fit your business needs. Mutable infrastructure in the sense, you can change to meet your business needs. So what do you mean by mutable here? You can easily introduce updates to the existing version of your software, and you can do the patches and you can do the scaling. What does it mean here? Suppose I have a infrastructure already. I have an infrastructure. This is my, let's consider this is one VM. Now my current requirement is I want to deploy this application I developed initial release on this Java software 1.8 Tomcat 8.5. I need to deploy this version of the application. Now later there is a change. There is a change in the demand. There is a change in the code, and these guys developed a new package. Let's say these guys developed a new package. Let's say 2.0 version. 2.0 version, and their requirement is they want to deploy with the Tomcat 9 or maybe JDK 11. They introduce some new, they are using some Java 11 features, and if I have to deploy this application in that server, existing server, you already have an infrastructure, you are updating your existing servers only. So if I have to deploy this one, I need to update this software's versions, I need to deploy the latest code. So you are updating the existing infrastructure to release new versions of the codes. You are doing some kind of a version upgrade, patches like this. This is mutable infrastructure. Your infrastructure is can be updated with the latest versions of the applications, latest versions of the softwares like this. This is called as a mutable. You are continuously using same server to deploy new versions. Let's say later you want to deploy 3.0 version, right, with the Java 11 like that. This is a mutable infrastructure. But when it comes to immutable infrastructure, it is like you are completely replacing that infrastructure itself for new versions. Immutable infrastructure cannot be changed, once it is deployed. If you want to make any alterations, if you want to make any updates in that servers, you want to make some updates that can be application version update, that can be a software version update. So you have to replace that whole infrastructure with new version. You have to replace the whole infrastructure with new version. Since versions are independent, you can easily roll back and track themselves, and you can enjoy the consistency and predictability. So immutable is preferred. Immutable infrastructure is preferred. Suppose you have already deployed one application like this, right? If there is a new requirement in this application, you need to deploy latest version of the application. Instead of updating this softwares and versions in the same server, you provision the new server, different server. You start deploying the new changes completely here, new changes completely here with new code. So this is immutable. Any change to your application, you are going to bring a new infrastructure for that application updates. If any change to your applications, you want to update that application or that softwares, you are going to bring a new infrastructure for this one. This is called as immutable. Suppose again there is a change in the code. Instead of updating the existing infrastructure resource, instead of updating the existing infrastructure server, what I can do, I can apply, we can provision a new server, and in this new server we are going to deploy the updated version. That patches or upgrades will result in new infrastructure. This is immutable infrastructure. Which one is recommended here again with the cloud? If you guys are going with cloud, which one is recommended again here? Recommended one is immutable. Because if I am trying to keep on doing lot of version upgrades in the same server, same infrastructure, do you have a possibility of that configuration drift? Do you lose the control? Do you lose the control what versions are running in what systems like that? You are keep on updating applications and software versions. In this one, there is a chance for configuration drift. And also, let's say something is not working with this version, again, do you need to do a lot of rework to go back to the previous software versions, previous application versions, if it is a mutable infrastructure? Yes. But if it is a immutable infrastructure, you are managing that code, infrastructure as a code. So can I just revert my changes in the infrastructure as a code? Can I reprovision the whole servers with that configurations also if required? Yes. So immutable infrastructure is recommended. But using Terraform, you can build mutable infrastructure also. You can go with immutable infrastructure also. But you need to decide which one is going to work as per your needs. You need to consider your needs, whether I need to go with mutable infrastructure, whether I want to go with immutable infrastructure. Mutable infrastructure in the sense, it's like a combination of configuration management plus provisioning. So if I have to build mutable infrastructure, can I just do this one? Using Terraform only, creating a servers using Terraform, provisioning? Can I do only this one using Terraform? Yes. Then can I leave this one? To configuration management tools like Ansible? Once the servers are provisioned, can I do the required configurations, required deployments like this using Ansible? Yes. But If you have to go with immutable infrastructure, there is a templating tools. There is a templating tools. If you have to go with immutable infrastructure, there is a templating tools. I hope you guys are familiar with the templating. So Docker, Docker also can I consider as a templating? Templates, can I build a templates? Can I build a packages for my applications using Docker? When it comes to containers, yes. And let's say, can I go for a Packer also kind of a templating tool, templating tools. Can I go with the templating tools for creating a templates packages for machine images also if required? Packer, Hashika Packer. If you guys already familiar with AWS, right? In AWS you have something called AMI. In AWS you have something called AMI. AMI is a pre-configured package. Using Packer, can I create a image? Can I create a image with all these things also if required? A machine image with all these things also if required? OS plus required configurations and required code also. Can I do that using AMI? We discussed about AMIs, right? We discussed about AMIs. What is AMI, guys? What is AMI? Amazon machine image. So if required, when you guys are going with the virtualized deployment, when you guys are going with virtualized deployment, I hope you can understand virtualized deployment and containerized deployments. So if you are going with virtualized deployment, if required, using using Packer, using Packer, you can create a AMI. Can I create a AMI with whatever OS I need? That can be Red Hat OS, that can be Ubuntu OS, CentOS, or whatever it is. Yes. Plus, can I create a AMI with required softwares and configurations also using Packer templating? Yes. Required softwares. You can create a predefined templates, predefined images, required softwares and configurations, plus code also. And can I use this AMI? Can I use this AMI, whatever has been pre-built, pre-packaged and pre-built AMI? Can I use that AMI to create a machine so that that machine will have everything like this also? If you do all these things using templating tools, if you do all these things using templating tools, right? Will I have everything in that machine? Yes. So here, do you need to do some kind of a configuration management, that mutability? That mutability here not required. So you use this your own templating features like a Packer, and you build your own AMI with required OS, required softwares and configuration plus code also. If you guys are following virtualized deployment, but any change to my code, can I create another AMI, one more AMI with everything like this? The AMI with everything like this also. If you guys are following a virtualized deployment, can I build AMI like this? Yes. So you build this AMI in my Terraform script. Can I update our infrastructure as a code? Forget about Terraform as of now. In my infrastructure as a code tool, can I say use this AMI? So since there is a change in the desired state, when I apply that infrastructure as a code tool, will it bring one server like this? If I apply, if this is the AMI which contains, is it going to bring this one? If I am doing this approach, is it a mutable infrastructure or immutable infrastructure? This one, this is immutable, which means you are any change to your application, you are provisioning the new servers, you are provisioning the new infrastructure. What is the advantage, right? Suppose something is not working with this one, can I just update my infrastructure as a code to again go with this AMI, so that is this will be terminated again? Again will I get this one if I go with old template, old AMI? Yes. So will it avoid this configuration drift? Will it avoid this configuration drift, which is going to happen if you are going with the mutable infrastructure? Yes. So you can use kind of a templating. You can use some kind of a templating to go with immutable infrastructure. But do you need to decide before you plan your IAC what you have to do, whether you need to go with the mutable infrastructure, whether you need to go with immutable infrastructure? Do you need to decide in the beginning itself? Because you need to decide whether I need to go with the templates, these type of templates to build my applications and infrastructure together, or can I just go with the plain templates, only infrastructure, no softwares? You need to decide before itself. If you guys are using, virtualized deployment this way, if you guys are using virtualized deployment this way, but if you guys are using containerized deployments, can I provision just my Kubernetes clusters using Terraform? Can I leave? Because you know how containers work. So in containerization, you can only build a templates with the softwares and code, no OS. If required, can I use Terraform to provision my Kubernetes clusters, and can I use Docker templates to deploy my applications, the Docker images to deploy that applications into a Kubernetes cluster? Yes. And again, whenever you are updating your application, whole application is getting replaced. But if you want to upgrade your Kubernetes versions itself, can I update that infrastructure as a code tool saying that use 1.25 version of Kubernetes, like that? So which will produce a new cluster, So you can go with the combination of templating tools with Terraform, or you can go with the combination of Terraform with configuration management tool. Understand the tool. Terraform can be used with configuration management tools like Ansible, and once you provision the infrastructure, you set up the configurations again using Ansible. Or can I go with the templatings with the Terraform, like a Packer? Can I use Packer to build AMIs as per my needs, and can I use those AMIs in my Terraform script, so that the configurations with the infrastructure also will be provisioned? Yes. So based on your requirement, whether you want to go with mutable infrastructure or immutable infrastructure, again, whether which combinations you have to use, whether you are going with only Terraform or Packers with the Terraform, or whatever it is, based on your requirement you can use. So is everyone clear? What do you mean by mutable infrastructure? What do you mean by immutable infrastructure when it comes to infrastructure? There are a lot of combinations you can use, guys. So in the event of changes or updates need to be made, a entirely new instance with the proper modifications is deployed into the server. So if you go with immutable infrastructure, any changes you want to made at your infrastructure level, in your server level, you can bring a new instance with that new changes. Is everyone clear? As I already told, immutable infrastructure is considered as a preferred method, since it actually delivers all of the benefits of IAC. So far, we discussed about what is IAC, what is the advantages with IAC, and when it comes to IAC, infrastructure as a code, there are two things: imperative versus declarative. So declarative is very easy to use. You just define what you need. That tool will take care how to achieve. You just define your end result. You just define your end result. The tool will take care how to achieve that one. But if you are going with imperative, you need to do manually one after the other, manually one after the other, and that is not a correct way of managing again. And when it comes to infrastructure, you can go with mutable infrastructure or immutable infrastructure. Any questions, any doubts you have? Whatever has been discussed so far, we have not started anything with Terraform. Now, if everyone is clear, let's see the tools. We have various tools available. You have various tools available for going with IAC. So there are a lot of tools available: Terraform, Cloud Formation, AWS Resource Manager, Google Deployment Manager, Pulumi, Ansible, Chef, Puppet, SaltStack, like this. So these four using Ansible also you can provision the servers, guys. I will not teach Packer here, guys. I will not teach Packer. I'll just teach only Terraform. I'll not teach Packer here. Okay. So Packer is different tool again. So when it comes to these four, right? Ansible, Chef, Puppet, and SaltStack, these are widely used. These are widely used for what category? You might have already know. Bhaskar sir might have explained when he was explaining Ansible. These are widely used for configuration management. But if required you can create an infrastructure also, guys. Not sure how many are aware, there is a module when it comes to Ansible. There is a module, Ansible EC2 module. So by writing a playbook, you can provision the EC2 instance also, something like this. You define something like this. So it will provision the EC2 instance. In your Ansible playbook, if you write like this also, it will provision the EC2 instance. You are saying you are writing one task. So create a instance in this subnet with this instance type. Using this AMI, you create a instance. You can do some level of provisioning using Ansible also. But the problem here is this is not going to maintain any state. If I run this same script, same Ansible playbook 2-3 times, even though I am not changing anything, what will happen, right? It will try to create again and again the servers. Same server with same configurations, it is going to duplicate your infrastructure because Ansible is not maintaining any state. It is not maintaining any state. This is again kind of a procedural. This is kind of a procedural language, not a declarative. So let's say you are saying you want to create this EC2 in some subnet, but there is no subnet with this name. But again, this subnet creation you have specified in a different order. Again, it is not going to identify the dependency. So before creating this EC2 instance, if it has to create this subnet, you need to define in a proper order. First you need to create a subnet. Then you need to create a EC2 instance, like that. Procedural language you need to define. So it is not going to identify the dependencies, what has to be provisioned. So you need to tell Ansible what needs to be done. To achieve something. But if I go with Terraform, can I just say what I need? How it will be achieved will be taken care by Terraform, because Terraform is declarative. It will identify the dependencies also. It will provision those dependencies first, and also it is going to maintain the state. Without modifying my desired state, right? It will not update any infrastructure resources. So Terraform is only designed for I mean to say Ansible is more used as a configuration management, not as a provisioning, but it can do some level of provisioning also, but that is not declarative, imperative. So when it comes to Terraform, it's an infrastructure as a code tool. It is only used for provisioning, and you can do some level of configurations also. And CloudFormation also infrastructure as a code. Yeah, Azure Resource Manager also infrastructure as a code. Google Cloud Deployment Manager also infrastructure as a code. But these are cloud specific. These are cloud specific. If I'm using CloudFormation, it will work with only AWS cloud. If I'm going with Azure Resource Manager, it will work with only Azure cloud. If I go with the Google Cloud Deployment Manager, it will work only with Google cloud. But when it comes to Terraform, it is cloud agnostic. When it comes to Terraform, it is cloud agnostic. When it comes to Terraform, it is cloud agnostic. So what do you mean by cloud agnostic? Let's understand the difference between Terraform and CloudFormation. So Terraform is developed by HashiCorp company. Terraform is developed by HashiCorp company. Can I use Terraform with any cloud providers like AWS or Azure or GCP or DigitalOcean or IBM Cloud or Red Hat Cloud or VMware Cloud like that? Yes. So Terraform we can use with any cloud provider. Terraform we can use with any cloud provider. That can be AWS or that can be Azure, that can be GCP, that can be DigitalOcean like that. But if I am using CloudFormation, it is cloud specific. Is CloudFormation will work only with AWS only? Yes, only with AWS, right? Terraform uses kind of a HashiCorp language, the declarative language. You are going to write a Terraform script using HashiCorp language, that HCL, HashiCorp configuration language. It is built by a HashiCorp. It is it is compatible. It is like a JSON. It is like fully compatible with JSON format. But when it comes to CloudFormation, it utilizes either JSON or YML. And again, there are limitations when it comes to CloudFormation. Your CloudFormation YMLs, your CloudFormation templates cannot exceed this much size again. So Terraform is cloud agnostic. You can use Terraform to manage resources in any cloud platform like AWS or Azure or GCP. Not only cloud platforms. If there is a provider, for VMware, can we provision the resources in your own on-prem environments also if there is a provider? Yes. So people might confuse, sir, can't we use Terraform with on-prem? Yes, you can use with on-prem also. If on-prem has a providers, your VMware has a provider. If you guys are using VMware ESXi servers, you can manage infrastructure in on-prem also using Terraform. And the difference between Terraform and Ansible. As I already told, Terraform is open source tool which is provided by HashiCorp. Ansible is also open source tool. But Terraform is an infrastructure as a code, which means they are designed to provision the infrastructures. But when it comes to Ansible, Ansible is a configuration management tool, which means Ansible is designed to install and manage softwares on the existing servers. Ansible is configuration management tool. They designed to install and manage softwares on the existing servers. But there are modules available to build your infrastructure also, but that is not matured enough to identify the dependencies. You need to tell Ansible what needs to be done also. Ansible don't know how to do. You need to define step-by-step procedural steps. And again, Ansible does not maintain the state when it comes to infrastructure. So Ansible primarily designed for configuration management. Terraform is ideal. For creating and managing the infrastructure. Ansible is ideal for software provisioning, application deployments, or configuration management. So is everyone clear? What is configuration management, what is provisioning, what is Terraform, what is Ansible, what is what at high level. So this is just an introduction session and very, very important topic again before we start Terraform. So tomorrow I'm going to start actual Terraform. What is Terraform? What are the advantages with the Terraform? How to install Terraform? What concepts are there in Terraform? We will start actual Terraform tomorrow, and we will understand the Terraform architecture also, how Terraform works with various providers. We'll start actual Terraform tomorrow. So today is an introduction session for IAC, advantages with IAC, provisioning versus configuration management, declarative versus imperative, mutable versus immutable, we discussed. And some people can use Pulumi also. Some people are using Pulumi. Pulumi. Pulumi is again one of the infrastructure as a code, but Pulumi is a program, programmatic language knowledge is required. So you need to have a Go development language or Python development language to use Pulumi. Instead of Packer, can we use Amazon AMI? If you don't know Packer, using Packer you are building AMIs. Using Packer you are building AMIs only. You are building Amazon AMIs only using Packer. Using Packer you can build machine images, like that can be in AWS AMI, Amazon AMIs. In Google Cloud you can build Google machine images. In Azure Cloud you can build Azure machine images using Packer. Packer is a templating language for machine images. Machine images. Docker is a templating kind of a for container images. So using Packer you can build AMIs only. Using Packer you can create and maintain the AMIs in your cloud, and using that AMI ID, you can provision your infrastructure using Terraform. So since that AMI has everything, so you no need to worry about what configuration, what softwares needs to be installed, because you create a AMI machine image using Packer. That Packer, using Packer you can build your own AMIs with required OS, required configurations also. So Packer is a different tool, but I thought of explaining what is that also. Any questions? Any confusions here? What is what? If not, thank you. That's it for today. So tomorrow we'll start with actual Terraform. We'll continue tomorrow, guys. Thank you. We'll see you tomorrow.